Today I've just done a session. This was about Azure machine learning. This was very interesting because during the keynote I saw a machine learning session as well, so ML.net, which was very interesting. And a lot of people who were in my session actually were able to see both that session, which was mainly done with code, and session with Azure machine learning, which is mainly done by drag and drop. So I think it is important for people who have not used machine learning before. And in my session, I've asked, and only 5 or 6 people used machine learning before. The vast majority never used it before. So I think it's a good idea to explain how machine learning works, and afterwards to actually show them how they can do machine learning using Azure in this case. And in most situations you can just do drag and drop, which is fairly easy for someone just beginning with machine learning. You don't have to learn all the complicated math stuff and all the insides of the algorithms and all that. It's very simple for them, just drag and drop, and later on, after they have that knowledge, they can expand to a deeper knowledge in which they create their own algorithms. They use ML.net, and they move on to more advanced and more interesting things. The second session I'm going to do, which is going to be at the end of the day, is about cognitive services. So cognitive services are something that's ever changing. So 6 months ago, we were able to present cognitive services about certain things. Some of them don't exist anymore, but others now exist. For instance, emotion detection doesn't exist anymore. It's integrated into face detection, which, makes sense. You don't need to have a separate thing. Within 2 weeks after I've done this interview, they're probably going to change this for something else. So this keeps changing, but it's very interesting that with also a few lines of code, you can actually interact with some web service somewhere in the cloud, send them pictures or sound or video including, and actually get the results out, such as, okay, what is this image doing? What are the people doing here? What is the scenery? Who is this famous person? Are they happy? Are they sad? Are they male, female? How old they are? They usually assume I'm 50, which is obviously wrong. I'm 18, but everyone knows that, except the computer. And you can actually detect all of those stuff like emotions. If a person is happy, if a person is sad, you can actually detect that. So this kind of technology is already being used. So if you look at Facebook actually has, when you upload an image, it actually has a description of the image saying this is a person jumping, doing this, doing that, on a scenery of this and that. So that information already exists. So these kind of services are already being used a lot. If you consider a few years ago when Facebook started stuff like the translation, at the time they used Bing Translate very early on, and that was actually very correct translation for things. So Bing Translate is actually one of the cognitive services that exists that actually works really well. Technically better than Google. Some things are better in Google, but translation is definitely better in Bing. So some of these things are in practice at the moment. They are very good already. I would say that some of the services are up to 90% quality, 95% quality. Some of them are less, but I would say that maybe in 2-3 years, a lot of these things are going to go to a level where you can't distinguish the decision from a human than from a person. For instance, such as bots. Bots are something that's doesn't work really well at the moment because bots are very limited to the information that they feed them. But with time, within 1-2 years, I'm expecting the bots to interact just like a perfectly normal person and talk to you like, oh, it's a good day outside. Yes. What do you think about the weather? Oh, I think it's going to rain. You probably shouldn't do any swimming or something like that, because they can interact not just from the information that they have, but also from context that they learned from you, and actually take that information and act like a real person and actually give you valuable advice instead of you asking for those advice. Yes, this is a problem, and this is a problem not only about technology, but also about regulation. Hopefully the people who are watching might have been to a session yesterday on ethics and AI by Daria from Microsoft. That is actually a very important thing to understand before you get into this world. It's not like Skynet. Things are they're gonna take over and kill all the humans. Probably not, but you never know. So one of the things you should take into account is there are limits. What kind of limits do you need to set? And I'm not exactly an expert on this thing. Mostly politicians will probably be the best people to actually talk about this kind of problems. But there are some limits which you need to set. So humans will be able to do certain things. Machines should not be able to do certain things or access certain parts of information or just override certain situations. For instance, if this is a medical thing, the final result, the final decision should always be up to a person, if that is possible. This can be applied, for instance, to driving. So everyone has an app. The funny thing is, if you're driving from point A to point B and there's traffic, they say something like, oh, it's going to take half an hour. That's fine. So if you accept half an hour, you just drive the recommended routes and you probably arrive within half an hour. But if you are a human and if you say, look, I know this, but this is the usual time I leave my house, and within 15 minutes, I know there's going to be traffic coming from that side, so this prediction is not going to work very well. So I, as a human, probably already know some extra information, which hopefully within a few years, automated learning will actually be able to take advantage of all that information and processes and give you correct information. But if there is a big accident, you can never predict that. So if you hear that on the radio, the algorithm might actually take 5 or 10 minutes to tell you this, and that's probably enough time for you to not be able to turn to a different route and actually go faster on the other sides. Also, there are some routes which are not indicated by the map, such as dirt routes and stuff like that. So sometimes if you go there, I've actually done that once and it saved me 30 minutes off the overall time. So that's a lot. That is a problem. And you've probably seen a lot of people, and taking the example I did about traffic, there are a lot of people who don't know how to read a map. So these are old-fashioned paper maps. And I remember when I was younger, there were no cell phones, or there were, but there weren't any apps. And you would have to look at the map and say, I'm going to go from here to there. And take this road, take left, right, etc. I would have to do that, or have a person next to me to actually tell me that. That would be okay. Nowadays, you have the computer. If the computer stops working, which happens, and you have a lot of films about the internet failing and all of that, everyone goes into panic. And just last week or 2 weeks ago, we had a problem with Facebook, that it was out for 1 day, half a day, and everyone was panicking. Everyone started to use Twitter. And ironically, this is a very interesting statistic. When Twitter or Facebook fails, I think it's either YouPorn or Pornhub actually have spikes in the ratings, which is okay. Do you have nothing better to do? But okay, that's fine. It's an interesting statistic, but at the same time, you understand that people don't go outside to actually see something or actually watch TV. They are just there in front of the computer trying to get it to work. Because for them, it's not about actually getting the service, it's about making sure they're online. It's a different kind of stress. So for people who are just born recently, a few years from now, they will always depend on all of the technology. So that's going to be a problem. Books is something that people make fun of books because no one knows what a book is. People know what books are, but for instance, no one actually does math by hands, complicated math. They actually use the calculator, and that's fine. Everyone does that. It's practical. But if that fails, if you have no calculator at the time, you need to do it in some way. Let's imagine people at the space station or something like that. I'm assuming they have calculators there, but what if they didn't? Their life would depend on that, so they would need to know how to do the math by themselves. The accumulation of information does exist, and it is a current problem at the moment. So 10 years ago, people would just use normal information systems. They would receive normal information like person's name and basic stuff. Nowadays, you have stuff like IoT, and the biggest driver here is IoT because you can get information from other places like websites, trending, internet trends and all of that. But for instance, IoT is probably the biggest hog in terms of information, and they can receive thousands and thousands of measurements per second. So that becomes a very big problem. So what do you do with the information? Microsoft actually has a lot of technologies, and not just Microsoft, also the competition, which is very healthy because this makes sure that people actually speed up and develop things quite quickly, sometimes quicker than people can evolve to. But one of the things that people are starting to use now in IoT is to actually do stuff in the edge. That is, instead of actually putting all the information into the cloud, into a central server, they process the information, they do averages, sums, they do whatever they need to do with the information. Like if it's a temperature information, they do the average for 5 minutes, or whatever information they actually want to record, but not all the measurements every second. So they gather all that together somewhere in the edge, somewhere close to the source of information and what is being transmitted, because that is also a bottleneck, the actual transmission capability. What's being transmitted is actually very small information. Things can actually handle in intelligent ways. You don't have to accumulate every information. Just because the cloud accumulates 2 to the power of some big number, that doesn't mean you want to store all that information, because doing so will actually cost you money. So you want to save money. So this is also an issue. One of the things you can actually do is to actually be intelligent and do creative things with the information. Also, there are a few other technologies which are coming up just on the subject, for instance, stuff like blockchain. But the funny thing is that if you use blockchain, like some people wanted to use it like for Bitcoins and stuff like that, and to replace Visa, the current Visa network, just to mention one of the players, actually allows for 50,000 times more transactions than Bitcoins allow at present time. So 50,000 times more. So that means that if you want to replace all of the infrastructure for Visa, MasterCard, and all the competition with blockchain, you need to have an infrastructure which is not 50,000 times more, but much bigger than that. And I actually did the math how much it would cost. And basically, not in terms of money, but in terms of energy. And the funny thing is that the energy necessary to power all the payments in the world using something like blockchain, Bitcoin, some technology similar to that, would cost you about 3 or 4 suns, I mean actual star suns per year. So that means you fry the earth with the amount of energy that you need. And this is conservative thinking, because in reality, I'm assuming that I did this math as a low value, but I'm assuming it's more. So this technology is not suited for this. This generates a lot of extra noise, a lot of extra stuff that you don't need. So you always need to use the right technology for the right problem. All of these technologies where you store information in multiple ways, there are a lot of different ways to do things, and you have to pick the right technology to do the job, while many people, like mostly politicians and managers who are, oh, I'm crazy, let's use blockchain, this is good, they actually try to use the technology and adapt the problem to the technology. It should be the other way around. The problem should drive the selection of technology, not the other way around. The conference itself, it's very big. It's very big tracks. I wasn't able to check all of the sessions. Obviously, there are a few interesting sessions. I wasn't the keynote. The keynote was interesting. One of the things I noticed that the keynote was done in Croatian, which makes sense because 99% of the people either are from Croatia or from neighboring countries that have similar language understanding. But I was actually able to understand the keynotes. Because I saw the slides, they were in English, so that helps. But at the same time, especially the ML.NET demo was very interesting for me, because I could actually understand everything in the demo based on what I was seeing. And obviously there are a few words like machine learning, that's a word that you see in English as well. But all of the other words like model and algorithm and all that, I can understand those words. The rest in the middle, I had to take from context, which was fine. But anyway, this was something that wasn't scary for me. So for instance, if someone was to speak Japanese, that would be very different. But for here, I actually was able to understand things, which for me is very nice.